Hello students to my channel Pharmaceutical Concepts. Let us learn together about volumetric analysis, some important terminologies and the meaning of volumetric analysis. So this volumetric analysis, basically it falls under the category of the pharmaceutical analysis. It is one of the very important methods of the sample analysis in pharmaceutical analysis. So as you all are aware about the applications of pharmaceutical analysis, which are mainly dealing with the qualitative and quantitative analysis, okay, and quantitative analysis. So this qualitative analysis means it mainly deals with the identification of the unknown substance, unknown chemical compound, and suppose if we identify also that yes, the given sample is this particular compound, then how much that compound is present, so what is its concentration, that can be found out by the various techniques or various methods under quantitative analysis. So this volumetric analysis is one such quantitative analysis technique where we measure. Metric means what? Metric means measurement. So we measure volume of the reagent. Okay, we measure volume of the reagent, and from that volume, this volume of the standard solution which we are measuring, that helps us in finding out the concentration of the unknown compound. So how it is exactly done, what are the various types of volumetric analysis, that will be covered in the next video. Now for time being, let us just understand volumetric analysis is the measurement of the volume. Let us see the definition. So it includes determination of volume of solution of accurately known concentration required to react completely with the solution or substance to be determined. So the solution or substance to be determined, I generally call it as sample. Okay, why I call this substance or solution as sample? Because I do not know its concentration. I have to find out its concentration, and that is the aim of this experiment, that I do not know concentration of the certain chemical compound present in this particular solution. I have to find out its concentration, and that can be done by using a solution of accurately known concentration. I call this solution as standard. Okay, so standard solution concentration is already known. Okay, so from known concentration of the standard solution, we find out unknown concentration of the sample. This is done in quantitative analysis. Okay, and yes, it includes determination of volume. So how much volume of this standard solution was required to react with this sample solution, that will give us the idea about the concentration of the sample present in that particular solution. Let us know various terms used in titrimetric analysis. The first is standard solution. So as I told you, I call it as standard solution because its concentration is known. Then there is another term called as sample, which can also be called as analyte or titrant or titrate. Now this sample solution I take in the conical flask. Sample solution I take in conical flask. So I'll have a conical flask. In this conical flask, I'll take the substance. Okay, I'll weigh the amount of substance which is stated as per the standard procedure, and then I'll add some solvent to it. I'll add some other reagents required, and I'll add indicator into it. Okay, so this everything will be taken in conical flask. Next, the standard solution which I call as titrant, that standard solution of the known concentration is taken in the burette which is calibrated. So it is taken in the calibrated burette. Then the indicator, as I mentioned you, it has also been added into the conical flask along with the sample solution. So this indicator will help me to understand when the reaction of standard and sample is completed. Okay, so it gives me idea about the completion of reaction between standard and sample by some visual changes. So these visual changes could be in the form of maybe color change or some formation of precipitate or formation of complex, which can also be seen as the color change. Okay, so we will learn more about it in the subsequent slides. And the next important term is endpoint and equivalence point. Yes, these two terms are different. These are not same. There is little difference between endpoint and equivalence point. So that also you will see in the subsequent slides. So let us understand now what is standard solution. So it's a solution of accurately known strength. Strength means what? Strength means concentration. Means it's a solution of known concentration. That is accurately known concentration. What do we understand by the term concentration? Okay, suppose I weigh 1 gram of the compound, for example any drug, 1 gram I am weighing. So this 1 gram is the amount of drug which I have weighed. Now when I add this 1 gram of the drug in 100 ml solvent, okay, so that becomes 1 gram per 100 ml as the concentration of that particular solution. See, this 100 ml is the solvent. This 1 gram is the amount of drug I am adding into that solvent. So now that has become 1 gram per 100 ml. Okay, so I will just convert or convert this particular concentration in this form, like in 100 ml 1 gram. So 1 gram is nothing but 1000 milligrams of drug is present in 100 ml. Okay, so I have just converted it into milligrams. Now in 100 ml if this much is present, then in 1 ml how much drug is present? Okay, so this x, and this x I can calculate as 1000 divided by 100. Okay, so that means 10 milligrams of drug is present in each ml of this flask. Okay, so this flask which is of 100 ml, in this we have added 1 gram of the substance. So this 1 gram is present in full 100 ml. तो उसके 1 ml में how much drug is present? So that is 10 milligrams per ml is the concentration of this particular solution. So this is just one of the ways of expressing concentration. In case of these titrations or titrimetric analysis, the concentrations are usually expressed in terms of normality and molarity. Then very pure reagents of high stability are used to prepare standard solutions. Yes, I call it as standard solution. That means that particular drug or that particular substance is very much pure. So when I say I am weighing 1 gram, means full 1 gram is that particular substance without any mixture, without any impurities in it. Okay. Next, accurately weighed amount is diluted to exact volume to obtain the desired concentration. Okay. Next is equivalence point. The equivalence point is when the moles of a standard solution become equal to the number of moles of solution of the analyte. Okay, so let us see how it is defined. It is a point in titration at which the amount of titrant added is just enough to completely react with the analyte solution. Okay, For example, for acid-base titration, the analyte is fully neutralized by addition of enough amount of titrant. Okay, for example, suppose in burette you have the base and in conical flask you have the acid which is present. Okay, so this is the simple acid base titration, right? And this base, as it will fall down in the acid drop by drop, it will start neutralizing that acid, each acid molecule. Okay, and I am adding one indicator also into it. Now this equivalent point is the theoretical end point. Okay, that means I am adding enough amount of base to this acid so that this full acid which is present in this flask is neutralized. Okay, so basically the volume of base here in this particular example, volume of this base required to completely neutralize this acid which is present in the flask, that theoretical volume is the equivalence point. Okay, at the equivalence point in an acid base titration, the number of base becomes equal to number of moles of acid, and the solution only contains salt and water. So suppose this base is nothing but NaOH. Okay, suppose this is 0.1 molar NaOH and this is also 0.1 molar HCl. Okay, this is a strong base, this is a strong acid, and this HCl plus NaOH will give me salt and water. Okay, this is how the neutralization reaction happens over here. Now at equivalence point, this will completely get converted. These two will completely get converted into salt and water at equivalence point. So addition of an indicator to the analyte solution helps us to visually detect the equivalence point. Okay, why I have added the indicator? Because if I see 0.1 molar NaOH solution that is colorless, transparent solution, 0.1 molar HCl is also a colorless solution, and the reaction which is happening, that is the formation of salt and water, that reaction is also is not associated with any color change or any physical change into the reaction, and therefore with my eyes I just cannot see any change in the flask happening. I will not understand whether this reaction is completed or not, and to understand that, these indicators are helping us. So in simple words, equivalence point is the theoretical completion of the reaction. So what is this indicator? These indicators are the complex organic compounds which show clear visual change after the reaction between titrant and titrate is just complete. So it is added to the analyte solution that is in conical flask, and it changes the color when the equivalence point is reached. Okay, so as I had shown you, this NaOH I am adding from the burette. Okay, so it is falling drop by drop into the conical flask where the acid is present. Okay, so once this reaction or neutralization is complete, once this reaction is complete, for example I am adding NaOH, this some molecules of acids are neutralized, next drop of NaOH some molecules of acid is neutralized, and in this way whole acid which was there in the flask is neutralized at one point. Now when the next drop of NaOH is falling down in this particular flask, that will make this solution basic now. Okay, and this indicator which I had added in this particular solution, this indicator possesses the property of showing different colors in acidic pH and in basic pH. Okay, suppose this particular indicator which I am adding here is colorless in acidic pH. So initially I don't see any color to the solution, and as soon as the solution turns basic, the color of the solution turns pink. This is because of the indicator which I had added in the analyte solution. Each type of titration has different sets of indicators. As I told you earlier, there are different types of titration like redox titration, precipitation titration, complexometric titrations. So each type of titration has different set of indicators. For example, in redox titrations, only those chemicals can be used as indicator which able to show different colors in their oxidized and reduced form. For example, yes, the methylene blue. Okay, so this methylene blue, it's blue in oxidized form, and when it is reduced, it becomes colorless. Phenolphthalein changes color depending on pH, hence it can be used for acid-base titration. So a complex organic compound that changes its color in response to chemical change is called as indicator. Okay, and the use of an indicator is key in performing the successful titration. The purpose of indicator is to show when enough standard solution has been added from the burette to fully react with the unknown compound present in the conical flask. Okay, so indicators must only be added to the solutions of unknown concentration when no visible reaction is occurring. And depending on the solution being titrated, the choice of indicator can become the key for the success of that titration. So now what is endpoint? So sometimes people use this endpoint and equivalence points terms interchangeably, but these two terms have a little line of demarcation between them. So endpoint is what is actually measured. That means a physical change in the solution which is determined by indicator, that is called as the endpoint. It is a point at which the indicator changes color. It's called as endpoint. There is slight difference between endpoint and the equivalence point of the titration, and this error is referred to as an indicator error, which is the indeterminate error. Okay, so equivalence point is the theoretical endpoint. That means suppose I am adding zero point 0.1 molar NaOH, which is a strong base. I am adding this to 0.1 molar HCl, which is in the flask, which is a strong acid. So the strong base strong acid reaction, and that too they are equimolar. So theoretically I can say that 15 ml of 0.1 molar NaOH can react with 15 ml of 0.1 molar HCl. This is the theoretical value. Okay, but practically there could be some errors, or there could be many other factors which because of which this end point, actually the color change which I see while practically performing this experiment, maybe I see color change at 15.9 ml. So this 0.9 ml is the error. Okay, and this 15.9 ml at which the color of the solution changed, that is called as end point of that particular titration, and this is the equivalence point of that titration. So how is this titration setup? If you uh, ask me, this burette will be there. Okay, and this burette is fully made up of course glass, and it is graduated. It has the graduation markings on it. Okay, so this burette will have the graduation markings, and usually the glasswares which we use for the titrimetric analysis. Okay, these glasswares should be calibrated. So this burette should be calibrated. Okay, the beakers, the conical flasks which we use, they are uh, fabricated for the approximate volumes. Okay, but the pipettes and burettes, okay, these all are expected to be calibrated. It is the main piece of equipment required for the titration, and calibration is very important because it is essential for the burette to be as accurate as possible in order to dispense very precise amounts of liquid into the sample. Okay, the process of addition of standard solution from burette into the solution of unknown concentration is known as titration. So this burette will have titrant into it. This will have the titrate or the analyte along with other reagents which are required and the indicators. Okay. Thank you for watching till the end. If you are new to my channel, please do subscribe for latest updates. Thank you again. Have a nice day.